in this video we are doing Calc AB Problem Set 25. The problems and a playlist are in the description below. Let's look at the problems. So first up, given that x squared y plus 3x plus 2y, I don't know why I'm having trouble reading this, plus 2y squared equals 7, find the equation of the tangent line at -2, 1. All right, we can do that. Find the coordinate of the points where the tangent line is horizontal. All right. Let's see, maybe this should have been a calculator problem for part B. I used a calculator, so I'm giving you permission to use a calculator on part B. Not on part A though. So the equation of the tangent line, we're gonna need the derivative, so we need to find the derivative with respect to x of both sides of this thing. I skipped writing this step, I'm just gonna go for it. First thing is a product rule, so we're gonna get first derivative of the second plus second derivative of the first. Plus the derivative of 3x is 3, the derivative of 2y squared is 4y dy dx, and the derivative of 7 is 0. Once you know what you're doing, that is the most common mistake I see, is forgetting to take the derivative of a constant. It's sad. It's a sad mistake to make because it makes most problems a lot harder, but whatever, don't do it. All right, now we're going to plug in -1, 2, so every x becomes -1, every y becomes a 2. I'm not going to make you watch that, so we just end up here. -1 squared dy dx plus 2 times -2 plus 3 plus 8 dy dx equals 0. There are 9 dy dx's, and then there's -1 constant, so move that over for 1, divide by 9. dy dx is 1/9. All right, hopefully you got that. Now, think it through for part B. We want the x-coordinate of the points where the tangent line is horizontal. What does it mean for a tangent line to be horizontal? It has a slope of 0. If it has a slope of 0, dy dx equals 0. So we already know, well, we don't really know. I went back to the beginning of part A and I solved for dy dx. So dy dx, you're going to move the 3 over to get -3. You're going to move the 2xy over to get -2xy. Then you're going to divide by the coefficients of x squared, which are x squared and plus 4y. So divide by x squared plus 4y. We need that to equal 0. So horizontal means the derivative is 0, which means that -3 minus 2xy is equal to 0. What do we do with that? Well, I'm going to solve that and get y is equal to 3 over -2x. So at this point, I'm thinking to myself, I'm kind of in trouble because I need to plug that in and solve. I think I'm going to end up with a cubic that I need to solve. I immediately was like, I'm just going to use a calculator because these are practice problems and you're not supposed to spend your whole life just doing practice problems. So I went to the calculator and I took x squared y plus 3x plus 2y squared equals 7, and I substituted y equals -3 over 2x. That gave me 3x over 2 plus 9 over 2x squared equals 7, which I definitely didn't want to mess with, so then I just asked the calculator to solve it. And the calculator gave me those 3 values. So those 3 values are our answers. So x is approximately -0.745, 0.891 and 520 because of that annoying rounding type of deal. All right, and then I was like, is this definitely right? So I also graphed it. So the calculator can graph. Seem to have crashed. Maybe. Yeah, I don't know why that happens. That's actually, so the thing that happens, not related, not important, but in another video I was like, oh, I think this thing crashed. It's somehow related to my desktop computer going to sleep, and I'm not entirely sure how, because these two things are not, I'm on an iPad doing this video. They're not linked or anything, but I think is somehow related to that. Not sure. So I graphed the function, not a function, I graphed the relation using relation graphing mode. And then I plotted the points and yeah, I think that the tangent lines are horizontal there. So I got 3 answers. You can't always check those because who knows what these graphs look like. But if you do have the opportunity, go for it. See if it really is accurate. All right, new problem. Find k that makes the function below continuous. So we have f of x is the square root of 5x squared minus 4, then minus 11, all over x minus 5 when x is not 5, and then just k when x is 5. So we know that for something to be continuous, the limit must exist, the function must exist, the limit must equal the value of the function. So in this case, I really need to find the limit because whatever the limit I get as x approaches 5, I'm just going to let k equal that, and then that'll force the function to be that value it'll force it to be continuous. So I'm finding the limit. Limit as x approaches 5, f of x. Remember, you don't care about what it is when x is 5, just when you're approaching 5. So that's going to be limit as x approaches 5, the branch that doesn't use 5. So square root of 5x squared minus 4, minus 11 all over x minus 5. I am choosing, this is kind of a weird thing, but like we've done so many problems like this. I looked at this and I was like, that's just a derivative. And it actually is a derivative. So the function would be square root of 5x squared minus 4. If you don't like this, just rationalize, right? That's like kind of always the alternative on this type of thing. Rationalize, multiply the top and the bottom by the radical thing plus 11. So over the radical thing plus 11. But I'm going to do it as a derivative. So that's my function, which means f of 5 would need to be 11, but it is. So that's f of x minus f of 5 over x minus 5. Alternate definition of the derivative. So f prime using the chain rule is going to be 1/2 the thing to the negative 1/2 times the derivative of the thing. So 1/2 5x squared minus 4 to the negative 1/2 times 10x. That's good. I'm going to plug in 5. So every x that I see becomes 5. I get 1/2. 121 to the negative 1/2, which is 1 over 11. And then times 50. So I get 25 over 11, which means that is the value of the limit. So now what I'm going to do is just like write up a solution because I don't know. I never know exactly like how far to go with these. Like the value of k is 25 over 11. But I just wrote, if k is 25 over 11, then the limit as x approaches 5 of f of x equals f of 5 equals 25 over 11. So f of x is continuous. Like we definitely answered it. We definitely did good work. Next problem. Find the velocity and acceleration of a particle moving according to the position equation x of t is sine squared of 3t. All right. So this is just an excuse to take derivatives really and to use proper notation. So the proper notation is that v of t is x prime of t. You have to connect those two or you're going to lose a point. I don't make the rules. And then this is a chain rule problem. We've done a lot of these. So something squared is 2 times that thing. The derivative of the thing is cosine of a new thing. The derivative of that thing is 3. I think it's a good idea to simplify this because you need to take the second derivative. If you don't need the second derivative, I don't know, you probably leave it. So v of t is 6 sine of 3t cosine of 3t. All right, next derivative. So I'm going to connect acceleration to velocity. A of t is v prime of t. Same idea. And then we're going to do 6 and then a product rule, right? So first or the second plus second derivative first. Chain rule where appropriate. So sine of 3t, negative 3 sine of 3t plus cosine of 3t times 3 cosine of 3t. So hopefully the chain rule is starting to be something that you like just do and you don't really think about. It's just like, yeah, I got this. I can take out 3 from like both of those products. And so one option for writing the answer would be a of t is 18 quantity cosine squared of 3t minus sine squared of 3t. Definitely one of the 14 formulas if you remember your trig formulas. But you could also leave this. I mean, if it's not multiple choice and you don't have to match like a tricky answer choice, I'd probably leave this. If not, a better thing to do actually is probably go back here and use the double angle formula for sine. So 2 sine cosine is sine of 2a. 2 sine a cosine a is sine of 2a. So 3 times 2 sine cosine is 3 times the sine of 6t. And then from there, we could find the derivative, using the chain rule, but it's just going to be 3 times 6 is going to be 18 and then cosine of 6t. So that's like, I think unquestionably easier, but like not mandatory usually in most calculus classes. I don't know, maybe the class you're in it is. Anyway, this problem set's done. Hope this was helpful and good luck.